Okay, so let's start today's session. I'm going to share my screen. I think it's visible. So today we will talk about quantum mechanics topic, but I think in the previous class there was one or more than one students were asking about that, like whatever we are going to share with them, they told that it is already given, it is already solved by another Nptel TA teacher. So that's why what I thought that I can explain the CSIR NET question paper also, because GATE and NET are very much equivalent. So if someone is going for the preparation of GATE, then so if someone is going to practice for GATE also, then he or she can also be able to practice the NET CSIR NET syllabus, because these two syllabus are very much equivalent. So as this today's class is on the basis of the quantum mechanics topic, so what I thought that obviously if I do the quantum mechanics from the previous year GATE topics, then maybe it may be possible that most of the questions has already been solved by the previous TA or some teachers, all these things. So that's why I did I also asked that one to our Nptel coordinator, and they said that okay, it is fine if you just discuss the NET questions also. So today we will talk about NET questions. Okay, so maybe it will not be it has not been discussed yet, so that's why I am going to start that. So it is today we will talk about 3 years question paper. One is NET 2018 December and NET 2018 NET 2018 December, NET 2018 June and 2017. So I don't know how much time I will get, but yeah, we will do that. So let's start today's session. Sorry? Sorry, I can't hear you properly. Can you tell me just a minute? Maybe my sound has some problem, or can you tell me again? I can add some. Can anyone repeat her question? I can't hear. Can you please write the chat box? Can I? Okay, there is something. It's better to write in the chat box, maybe. I can't hear you properly. Maybe my internet or your internet has problem. I don't understand. Okay, so you just write the problem, whatever you are asking, you can write in chat box, and in the meanwhile we can start, isn't it? Or should we wait for the question? Yeah, for question or addition also. Okay. okay, fine. So this class we will talk about NET, CSIR NET, and in the next class maybe or next to next class we will talk about TIFR also, if you people want. Okay, fine. So we will just start today's session, because it's already 6 minutes. 6 minutes has already gone. So first question from NET 2018 December. First question NET 2018 December. So the question number is 34. The ground state energy of an anisotropic harmonic oscillator described by the potential this is which? So first of all, I just want to tell you one disclaimer that the main paper of NET 2018 December paper was very much fuzzy. So that's why I have to download that question from another site. So okay, fine. Question is the question. That is the main thing. So the ground state energy of an anisotropic harmonic oscillator described by the potential this is how much that they are asking. So this is a very simple question. I know that most of the people has already gone through these things, but yeah, I'm just going to do that one a little bit quickly so that you can also have the feeling. So I'm just going to write that. So what is the question? Basically the question is saying that the potential is this one, Vxyz half m omega square x square plus 2m omega square y square plus 8m omega square z square in units of h bar omega. This is the potential, and they are asking that what will be the ground shell energy of that anisotropic harmonic oscillator. So first of all, let us write the potential here, half m omega square x square plus what was that, 2 and 8, okay, 2m omega square y square plus 8m omega square z square. Something is there in chat box, let me check. Okay, very good. Okay, so if like one of the student has already got the answer, so I am just going to do it quickly. See, for that type of questions, what I will do, basically half, like the general expression for the potential is like half m omega square s square x square y square z square, like that. Okay, so I am just going to put these things like omega square x square. First term is fine. The second term I can write it like half m omega square half m 2 omega whole square, because you can see that 2 square is 4 and 4 and by 2 is 2. So half m 2 omega whole square y square plus, for that case what I will do, half m, then here I need to write 8. So that means if I write here 4 omega, so 4 square, that means 16 divided by 2, that will give us 8 whole square z square. So why I should write these things? Because like our energy is like nx plus ny, so basically let me write here if that saves. So here you can see that half m omega x square, and omega x square is nothing but omega square, plus half m omega y square. I am going to circle that one because omega y square is equals to 2 omega square. Then again half m omega z square. So you can see from here omega x square is omega square, omega y square is how much? Omega y square is 2 omega square, 2 omega whole square, and omega z square is 4 omega whole square. So what is the advantage of this? Advantage means like I can get the value of omega x, omega y, omega z, right? So I can get the value of omega x, omega y and omega z. Now it's very simple that energy is what? Energy is like nx plus half, if it is like 3-dimensional, and you can see that there is x, y, z, 3 components are there, so that means it will be in 3-dimensional. So nx plus half into h bar omega x, ny plus half into h bar omega y plus nz plus half h bar omega z. Okay, now in the ground state they are asking that in the ground state what will be the energy, the ground state energy. So ground state means obviously for that condition that in the ground state nx, ny, nz all are 0. So our E will be like half, you can see here half h bar omega x. So omega x was what? Omega. Then half h bar omega y. Omega y was 2 omega. Half h bar omega z. Omega z was 4 omega. Right? So that's why I just write here half h bar, let's say omega is also there. 1 plus 2 plus 4. Then how much it is? 7 h bar omega divided by 2, because 6 plus 1 7. So now you can have the energy that 7 by 2 h bar omega, and in units of h bar omega they are asking the answer. So the answer will be this one, that 7 by 2. Okay. So for that question we need to do just basically very simply, we just need to calculate our potential in such a, we have to just write the potential in such a way that we can have the value of omega x, omega y and omega z properly, and after that we will write the energy in terms of omega x, omega y and omega z, and we will put these values there in that energy, then we can get the value of E. Okay. So I think there is no problem in that question, so that we can go to the next question. Is it fine? I hope so. Okay. Then we will go to the next question. So in that next, if you have any problem, you can just ask me, no problem. So here in that question, we will talk about again the NET 2018 December question paper, and the question number is 36. There was, I think, 35. So let the wave function of the electron in a hydrogen atom be this, where phi, n, l, m are the eigenstates of the Hamiltonian in the standard notation. The expectation value of the energy in this state is how much? They are asking these things. So first of all, we just want to write the wave function. So what is the wave function? I'm just going to write the wave function here. 1 by root 6. Maybe you can also do with me also, that is very good thing. Phi is 200, phi 200 r, then plus root over 2 by 3, phi 2 1 minus 1, phi 2 1 minus 1 r, minus 1 by root 6, phi 100 r, 100 r. So this is the wave function, and here they are telling that phi, n, l, m is the notation, standard notation. So that's why I'm just going to explain a little bit about that wave function. So if phi 200 is there, that means what? In that state, n is 2, l is 0, m is 0. Okay. Similarly, if I write phi 2 1 minus 1, n is 2, l is 1, m is minus 1, like that. Okay. So now they are asking that what is the value of expectation value of energy in that state. So how to do that? Basically, expectation value of energy. So how to calculate? So you can see here 1 by root over 6, phi 200. So phi 200. This is a this eigenstate has the value of n as 2, and our ground state of the hydrogen atom, it is talking about the hydrogen atom ground state. So the hydrogen atom ground state is how much? If I write here n equals to 1, then energy is like minus 13.6, right? So for phi 200, what will be the energy for that? Our energy depends on like E0 divided by n square. So if I write here phi 200, that means minus 13.6 divided by 2 square, which is minus 13.6 divided by 4. The energy for this state, but this state is how much in psi? This state is if I normalize that one, then 1 by 6. 1 by 6 into energy. So that means for first case, the energy will be like 1 by 6 into minus 13.6 divided by 4. This is coming from phi 200 state. Similarly, in the next case, root over 2 by 3, phi 2 1 minus 1. As I have already mentioned that En equals to minus 13.6 divided by n square. So you can see that in that expression there is no L and M. That means our phi 200 energy and phi 21 minus 1, this energy is exactly same, right? Because you can see here the n is also 2, here is also n equals to 2. So that means from that the energy is coming as minus 13.6 divided by 4. Similarly from here also minus 13.6 divided by 4. But how much is the contribution from this case? In psi, you can see here psi was 1 by root over 6, psi 200 plus root over 2 by 3, phi 2 1 minus 1 minus 1 by root 6, phi 100. So for that case, if I just write the energy, then 1 by 6 times minus 13.6 divided by 4, it is coming from here. Then from here 2 by 3 minus 13.6 divided by 4 plus 1 by 6 into, now this one 5100. 5100 means how much energy it will come? Definitely minus 13.6 divided by 1, because 1 square is 1, right? So that will be the energy of expectation value of the energy for that system psi. Now
shouldn't it be minus 1 by 6?
No, not 1 minus 1 by 6, because we are doing that psi. See, expectation of energy means what? It is like psi star E psi. So psi star psi. So psi star psi minus 1 by 6 is there, right? Another minus 1 by 6 is also coming here. So it is coming as 1 by 6. I mean, like minus 1 by root 6 minus 1 by root 6. So as a whole it will come as 1 by 6. Okay. So it is just a little bit shortcut, you can tell. So that's why our 1 by 6 is coming, not minus 1 by 6 is coming. Now this minus 13.6 divided by 1. Why this minus is coming? Because it is a simple eigenvalue. So eigenvalue has the minus value. So that's why we are writing here minus. If you don't understand, then I can elaborately write that one. That is also fine.
It's clear.
Okay, clear, fine. So now you can see here, if I just write here minus 13.6, then 1 by 24, like you just do the calculation right now, that is a very simple thing. Then plus 2 by 12 plus 1 by 6. So that will be the answer. So what will be the answer here? Just calculate. It will be 24, 1 plus 4 plus 4, then minus 13.6, then it is like 8, 9 divided by 24, and 9 divided, yes, 9 divided by 24, and 9 can be like 3 and 8, so minus 13.6 into 3 divided by 8. So how much will be it? So it will be like 40 divided by 8. So it will be minus 5.1. Yes, 5.1. So that will be the average energy for that wave function psi. So just let me check the which one is the correct one. Yes, this one is the correct one. So the D option is the correct one. Okay. So for that question, what we need to do, we need to calculate, we need to write the psi first, and after that the individual phi's, phi 200, phi 21, minus 1, phi 100, this has the energy eigenvalue, and we have to write that one, and how much contribution it is coming, we are just going to write that. Then the calculation will be very much simple. Mathematics is there, so we will calculate the energy or expectation value of the energy for the wave function psi, which will come as minus 5.1 electron volt. Okay. Okay. So now we can go to the next question. So this is the question number 56. So consider the operator. Operator is AX. AX equals to LY PZ minus LZ PY, where Li and Pi denote respectively the components of the angular momentum and momentum operators. The commutator AX, where X is the X component of the position operator, is how much? Can you see the screen basically? Is it visible? Hello? Is it visible? I hope it is. Hello? They will let you over. Okay. Okay. Can you see the screen?
Yes, ma'am.
Okay, fine. So, at which point I was disconnected? I could not understand. So,
From the first instruction.
this one?
Yeah, 56.
Okay, fine. So just we will talk about this question. So consider the operator Ax, Ly Pz minus Lz Py, where Li and Pi denote respectively the components of the angular momentum and momentum operators. The commutator Ax, where X is the X component of the position operator, is like the commutator is how much they are asking. Okay, so let's try to write that one. See, like commutator, we all know that A and B commutator is AB minus BA, right? But we just need to know some like very trivial commutator for our competitive exam, so that it will be very simple for us to calculate the answers, right? So I am going to write here Ax first. Oh, okay, sorry. Ax, and what is Ax? Ax is Ly Pz, Ly Pz minus Pz Ly x, right? So first of all, what I will write here? First of all, we can definitely do that one, minus Pz Ly x. So right now I will do explicitly all the steps so that you can understand clearly, but after completing the question, the answer, I will tell you that which step you should skip, okay, in your exam. See, basically this is like A, B, C.
Isn't the question Ly, Ax is equal to Ly Pz minus Lz Py?
Ax
Ax is equal to Ly Pz minus Lz Py.
Oh, sorry. sorry. I wrote wrongly. Okay. Sorry. Thank you. Ly Pz, Lz Py. Okay. Lz Py. Yeah. So, obviously, I will also be available to know that. Yeah. So, Lz Py. So, this is the case. So, now, you know, like, if it is like A, B, C, then what will be the answer of that? Like, I am going to expand that one. Then how to do that? AC B plus A B C, right? So I am going to do that one here for these two cases. But first of all, I will write all the terms, and after that I will tell you which one you should keep and which one you should skip. So A B C. So A C B plus A B C. Similarly here A C B plus A B C. Okay, I am going to write all the terms right now, but just see carefully. PZX commutator will give us 0 value. Why? Because our XPX or PXX, that type of combination will give us non-zero value, right? Other combinations like let's say XPY, XPZ, all this combination will give us a 0 value. So that means there is something in chat box. Just a minute, let me write. There is something. Oh, okay, very good. I don't know which one is the correct one, but yeah, we'll tell. But as you already did that one, that is very good. So that's why we will skip that part, that PZX we will not write. Wherever the PZX will come, we will definitely write that one as 0. Similarly, you can see here PXY. That term is also giving us 0 value, right? So we will left only these two. Now let me write here LYX, then PZ minus LZX, then PY. Okay? Now what we will do? We have to remember the expression of LY and LZ. So L is nothing but R cross P, right? Okay. So if I write here Ly, then what will be the like expression for Ly? Ly will be ZPX minus XPZ. You can do that, R cross P you can do, then you can find that Ly is ZPY, PX minus XPZ. Similarly, LZ we are talking. So same x, LZ is xpy minus ypx. So they are asking that Lyx, first term is Lyx pz. So I am writing here Lyx pz. So Ly is what? Ly is, you can see here, zpx minus xpz. So if I write here zpx x, this term will be non-zero. But if I write xpz, xpz x will give us 0 value, right? So we will not write that one, only we can write zpx x. Zpx x. Okay, for this time, for the first time I am going to write that one also. It will be x pz x as a whole pz. Now you can see here x pz x will give us 0 value. So we will only left with zpx x pz, right? So zpx x pz. So if I write here, it will come as z. Okay, pxx is how much? Pxx is minus IH bar, because x px is IH bar. So it will be minus IH bar pz. So this term is giving us the result minus IH bar zpz. Good. Okay. Now coming to the next one, LZXPY. LZXPY. So what is LZ? LZ is xpy minus ypx. Now you can tell me xpy x, that will give us 0 value because it is py and x combination. Now we will left only this part. This part is minus ypx x py. So minus y, then pxx. Pxx is again minus IH bar py. So the answer will be here minus of minus IH bar ypy. So from the first term it was coming as minus IH bar, if I write like that, zpz, and there is inbuilt one minus sign is there. Yes, there is one minus sign. So this minus and this minus will be as plus. So the answer will be minus IH bar zpz plus yp y. Because you can see that the for second term also minus IH bar is coming, and from the first term also minus IH bar is coming. So minus IH bar zpz, minus of minus, that means plus ypy. Okay, so we will check that which one is the correct one, zpz plus ypy. So zpz plus ypy. Okay, A is correct one. So whoever mentioned that B option in the chat box, maybe there will be a little bit confusion in that plus minus sign. So just check your answer. There will be one plus sign, not a minus sign. Okay, because the minus sign will be cancelled by the second term's minus sign. Here there is one minus sign, because this is a minus ypx. So can you please try it again so that it will give the option number A. Okay, so this type of questions are there. So we will go to the next question. Next question I have taken from June NET 2018 question paper, and the question number is 34. So what is the answer of that question? The particle of mass m is constrained to move in a circular ring of radius r. When a perturbation v prime equals to a by r square cos square phi, where a is a real constant, is added, the shift in energy of the ground state to first order in A is how much? Is it a by r square, 2a by r square, a by 2r square, a by r square? So what is the answer? in that question they are asking about the shift in energy of the ground state. So, and there is a perturbation V prime in the state. So it is nothing but a first order perturbation like question, first order perturbation theory. I think you all know these things. So first order perturbation, second order perturbation is there. So here in that question, very simple, a small perturbation is going to add in that energy. Then what will be the shift in that energy of the ground state? That is the question. So how to do that question? The function has to be known. Yes, good, very good. But here you can see, if I just see the function, like to know the function, we need to know some information. So what is the information they have already provided us? A particle of mass m constrained to move in a circular ring of radius r. This is the first known knowledge for having the expression of phi. I mean that ground state in wave function. So, do you understand anything about this? I mean, this line. From this line, can you understand any wave function? The wave function will be, let me write here, it is at phi 0 or something like ground state, so that means phi 0. That will be 1 by root over 2 pi only, because it is not dependent on r and theta as well as phi. A particle of mass m is constrained to move in a circular ring of radius r. You can see here circular ring of radius r, and the ground state for that case is 1 by root over 2 pi. That is a very well known wave function. If you just read any type of quantum mechanics textbook, you can see that a particle of mass m means like anything, that cannot be any problematic thing. A particle is constrained to move in a circular ring of radius r, has the ground state wave function 1 by root over 2 pi. So now if you got the wave function as 1 by root over 2 pi, you can have the answer also. So can you tell me what will be the answer? I am just going to write here V prime. V prime is what? A by r square cos square phi. This phi and this phi 0 is different. Don't mix with these things. Phi 0 means the ground state wave function, simple. And this phi is azimuth angle, basically, right? So what will be the energy? I mean that energy shift. Okay. So let's say I am writing here energy shift E11. So it will be like phi 0, let's say I am writing here phi 0, V prime phi 0. So what will be the answer here? 1 by root over 2 pi A by r square cos square phi 1 by root over 2 pi d phi, because you can see here there is only one variable is there, which is nothing but phi, and phi can go from 0 to 2 pi. So what will be the answer? 1 by 2 pi A by r square integration cos square phi d phi 0 to 2 pi. So what will be the answer here? A by 2 pi r square. Now I can do a simple integration, that let's say half 2 cos square phi d phi A by 4 pi r square. 2 cos square phi means 1 plus cos 2 phi d phi integration 0 to 2 pi then A by 4 pi r square phi plus sin 2 phi by 2 0 to 2 pi. Now A by 4 pi r square 0 to 2 pi phi, that means it will come as 2 pi, and here sin 4 pi 0 sin 0 0, so that means we don't need to do anything here. So it will be A by 2 r square. Pi will cancel out, 2 and 4 will cancel out, and it will give us 2. So A by 2 r square. So that will coming. You are talking that one? So see, basically the particle of mass m. Okay, for that case, let me write here. It is well known, but yeah, I can tell you. So a particle, let's say this one is a particle of mass m. M is anything, no problem. So m is here and it is moving in a circular radius, circular ring or something with a radius of r. Now you can see that like circle is there, right? So circle means the wave function can have the spherical polar coordinate, like which type of coordinate we are talking about, spherical polar coordinate, circle, and then Cartesian coordinate, right? But here there will be no Cartesian coordinate because it is rounding in a circle, right? So there will be a spherical polar coordinate like thing. But spherical polar is fine. But here you can see, let me write here psi as like psi or phi whatever. So in spherical polar coordinate in the ground state, what will be the expression? The expression can be as a function of r, theta, phi, right? Now the problem is here we are only talking about 2D case. 2D case means like there is our phi will be nothing and theta will be from 0 to 2 pi, isn't it? Because there we are going from, let's say, 1 point to 360 degree again. Okay. So our 2D, in the 2D case we are talking, and in the 2D case the ground state will be like that, only it will be a function of theta. And there will be one r, because it is a very simple the radius, I mean how much distance it is coming. But this distance will be cancelled out by the normalized factor. So the main wave function will be only dependent on theta, and the theta will go from 0 to 2 pi. So the psi function, it will come as a function of theta only, and this function will give us 0 to 2 pi case. I don't have right now the full calculation of the psi, I mean 1 by root over 2 pi how it is coming, but it is coming from the main motivation is that it is coming as phi equals to 0 case, and then our theta is going from 0 to 2 pi round, and our r and our psi is also independent of r, so that it will come after the normalization condition and all, it will come as only 1 by root over term. There will be no phi and there will be no r dependent term, as well as there will be no phi dependent term. So if you just want, then I can do you the full calculation maybe in the next class. I don't have that one right now, but yeah, sorry. You can see any textbook also that if it is a round circular case and the particle is moving on the circle, then the ground state wave function will be simple 1 by root over 2 pi. Okay, so you can also find any textbook also, but I think I can give you the solution next class also, maybe I also forget that one. Okay, so after that you can see a very simple calculation that phi 0 p prime phi 0 is there. So if you just going to calculate that one, then it is coming as a by 2r square. Okay, so now we can go to the next question. Next question is I have also taken the same from same question paper, June 2018. Okay, the question is 66. Okay, just see the question. At t equals to 0, the wave function of an otherwise free particle contained between two infinite walls at x equals to 0 and x equals to L is phi x equals to 0 is this much. Its wave function at the latter time is how much? Okay, so I think all of you has already attended that type of questions previously also, but I can tell you some trick on that so that you can simply very quickly do that one. Okay, so first of all, in that question they have already given that psi x at t equals to 0 the wave function, but we need to calculate psi x at t equals to m square by 4 pi h bar. That will be h bar. Okay, right. So we just want to calculate psi xt, and they have provided psi x t equals to 0. That's it. Okay, I hope you all understand the question at least. So now we will do the answer. Okay, so first of all I am just going to write here quickly t equals to 0. What is there? 1 by root over 2. Okay, root over 2 by L sine pi x by L minus sine 3 pi x by L. So if you remember correctly, then sine pi x by L, 3 pi x by L, that is nothing but for a free particle confined in a two-dimensional box, it is nothing but, let's say, psi 1 or phi 1, whatever you just mention it, and this is nothing but psi 3. Like if I write here correctly, then it will be like, this is a let's say any psi 1 state, and this is psi 3 state, because it is nx by L, n by x by L, right? So sin n by x by L, and n is 3 here, then you can see here that it is a psi 1 and it is a psi 3 state, right? So if it is a psi, I can write it like that. So root over 2 by L, this one, root over 2 by L, this one. So it is very well known that psi 1 minus psi 3, right? Psi 1 minus psi 3. I am just going to write it quickly. Now, what will happen at t equals to, what was that one? ml square by 4 pi h bar. ml square by 4 pi h bar. That means at t equals to non-zero value. At that time, what will happen? So psi x t, it will be nothing but psi 1 e to the power minus I e1 t by h bar, right? And then psi 3 e to the power minus I e3 t by h bar, because for that it is 3 and for that it will be 1. Okay. So now what will be the e1 and e3? E1 is what? E1 for that one-dimensional potential box, it will be like pi square h bar square by 2m L square. And what will be the E3? It will be n square pi square h bar square by 2m L square. So that means it will be 9 pi square h bar square by 2m L square. Okay. So E1 I know, E3 I know. So E1 and E3 I just want to put here, right? And you can see here t is also there. So t I can write by ml square by 4 pi h bar. Then what will be the answer here? Let us write here E1 t pi square h bar square 2ml square. Then t is ml square 4 pi h bar. 4 pi h bar. Okay. So if I write that one, then what will be the answer? See, pi h bar L square m. So it is pi by 8 and some h bar is there, right? Similarly, E3t will be what? You can see here E1 and E3, there is a very the difference between E1 and E3 is there, that in that E3 there is one 9 factor extra. So if I write here E3 8 also, then it will come as at 9 pi h bar by 8. Okay. So now I am just going here again psi t. So psi t equals to psi 1 e to the power minus I e1 t by h bar minus psi 3 e to the power minus I e3 t by h bar. And if I write here psi 1 e to the power, what was that? E1 t was pi by 8 h bar. So minus I pi by 8, because h bar will cancel out. Minus psi 3, it will be e to the power minus 9 I pi by 8. Okay. So now if I do here minus I pi by 8 common, then it will come as psi 1 minus psi 3. Now you can see here how much it will be. It will be minus I pi, because minus I pi by 8 will give us minus 9 I pi by 8. But what will be the value of minus I pi? Minus I pi has the value minus 1. Okay. That is the most crucial thing here, because most of the cases we forget that one to put a minus sign here, so that it will come as plus 1. Because e to the power minus I pi is there, and e to the power minus I pi value is minus 1. And that's why we have to put here psi 1 plus psi 3. Okay. Now psi 1 and psi 3, we just mentioned it psi 1 and psi 3, but right now we are going to write the full answer. Sin pi x by L plus sin 3 pi x by L. So just check that answer with the question. Okay, root over 2 something is there for the normalization. 2 by L is also there. Okay. So 2 by L sin pi x by L plus sin 3 pi x by L and e to the power minus I pi by 8 will be there as an answer. Now we will just see that answer. Pi by 8. But it should be plus 1, right? Because we have already calculated that it will be e to the power minus I pi by 8 plus 1. So maybe there is some typo. This is minus, right? So this is minus, so that should be plus. Or if it is plus, then there will be I pi by 8. Let me check. It was 8, right? Yeah, it was 8. So there should be plus. In that type of question is like, if in that wave function there is minus sign, in that like at time equals to this much, the wave function should be in plus, because e to the power minus I pi term should be there. So the answer will be, I mean, by the see, there is obviously a typo. See, B and D are the same, exactly same one. So it should not be the same one, right? So it will be 8 or it will be 8. Anyone will be 8. So that this answer will be the correct one. Yes, that this is a typo. You can see here B and D are the exactly same option, but they should not be the same option, right? So one will be 6 and one will be 8. Which one will be the 8 one? That will be the correct one. Okay. Maybe there is some typo is there. Obviously there is a typo. Because if there is minus, you can see in most of the cases the answer will be in the plus 1. That is the correct one. Because e to the power minus I pi should be there. So yeah, like either like if in D it is e to the power minus I pi by 8, then the D option will be the correct one. Because you can see B and D are exactly same. That should not be. Okay, so whatever, but I hope you just understand the question and you just understand the answer also. That like how to do that, obviously we should keep in mind that there is a e to the power minus I pi. Most of the cases we forget that one, so that's why we have already written that as minus only. But it should be plus. Okay, e to the power minus I pi by 8 and then psi 1 plus psi 3. Okay, I hope you understand. So we can go to the next question, and obviously I think there is one typo. I did not see that one like carefully. So maybe there will be a typo, and in that typo the D option will be the correct one. Okay. Okay, now go to the next question. This is from 2017 June, and the question number is 33. Okay, this is a very happy question. Okay, the two vectors are orthonormal if this. I think all of you knows these things, so just quickly do that one with me. So the two vectors are there and they are orthonormal in which condition? So orthonormal means what? Can you tell me orthonormal means what? Like if I write here psi 1 and psi 2, these two are orthonormal to each other, then what is the meaning of that? Do anyone know? Okay, if you don't know, then I can tell you. Orthonormal means there should be three conditions they have to satisfy. Psi 1 will be 1, psi 2 will be 1, psi1, psi2 will be 0, or similarly psi2, psi1 will be 0. This is the condition for orthonormal of two states. So if I write here one state as A0 and BC, then what will be the condition for orthonormal? Let us do that quickly. Let me write here A0, BC, right? So I told you first of all that psi1, psi1 should be 1. So if I do that, then what will be the answer? A0, A0, 1. That means A square should be 1. So A should be plus minus 1. Right? So first of all we already got the first value of A. Now what will be the B and C? So here psi2 is 1. So BC should be 1. So what will be the answer? B square plus C square should be 1. So this is one condition. In that condition you can't say exactly the value of B and C, right? Because B square plus C square is equals to 1 and there are two independent parameters and one solution is there. So you can't tell. But there is another solution. This is giving us 0. So A0, BC, 0. Now you can see that it is giving us AB equals to 0. But from the very first we already got that A equals to plus minus 1. So obviously A will not be the 0 option. So B will be 0. If B is 0, then we can come here again. If B is 0, then C square equals to 1 and C will be plus minus 1. Right? So the answer will be A equals to plus minus 1, B equals to 0 and C equals to plus minus 1. So let me check which one is the correct one. A equals to plus minus 1, B equals to 0, C equals to plus minus 1. So the C option will be the correct one. Is it clear? Okay, there is so many options is already given. Okay, good. So the option C will be the correct one. Okay. I hope there is no question on that and we will go to the next question. Okay. So the next question is again from NET 2017 June paper, and this question is the Coulomb potential is this one, minus C square by R of a hydrogen atom is perturbed by adding H prime equals to Bx square to the Hamiltonian. The first order correction to the ground state energy is how much, and the ground state wave function is already given here, this one. So we have to calculate that one. So very similarly whatever we have calculated there also, it is very similarly the same one, but there is only one thing we have to be very serious on that. You can see this is a R dependent function, right? That means it is in spherical polar coordinate. This is also in spherical polar coordinate, but whatever it is given here, that is not in spherical polar coordinate. It is in Cartesian coordinate. You can say here it is x. So what you need to do? You need to just convert our x in a spherical polar coordinate, so that other things are very similar, exactly whatever we have done. Okay, but the main thing is that our x should be written as, x is what in spherical polar coordinate? X is r sin theta cos phi. So we have to put this value in that h prime, and rest of the things are exactly same. Got it? I think yes. So should I do that one? Okay, let me write here. V was what? E square minus r minus e square by r, and the perturbation is what? Perturbation is h prime equals to bx square. Bx square. But it should not be x square. It will be b r square sin square theta cos square phi. That should be our h prime. That is the main trick. Otherwise all the things are very simple. So now what you need to do? You need to calculate simply psi 0, h prime psi 0. Then you can see here psi 0 star, h prime psi 0, b. Okay. Here also there is a trick, like dv is there, right? So dv will be in spherical polar coordinate, how much it will be? So psi 0 is already given here. Psi 0 is 1 by root over pi a0 cube e to the power minus r by a0. So 1 by pi a0 cube e to the power minus 2r by a0, because it is psi is there. And h prime is what? H prime is b r square sin square theta cos square phi, and then dv. dv will be what? dv will be like r square sin theta d theta d phi dr, and the limit will be from, I am going to write here the just simple this. Let's say r equals to 0 to infinity e to the power minus 2r by a0. Now you can see here, okay, our b is there, so I can put it here outside, and here r square, so that means r to the power 4 and then dr. Now theta equals to 0 to 2 pi, 0 to pi, phi is 0 to 2 pi. So theta is what? Sin cube theta d theta, then phi 0 to 2 pi cos square phi d phi. So that will be the full answer. I mean, if I do the calculation, that will be the full answer for that question. So will you do, or I can also do? That is a gamma function. You can see that will come as a gamma function, and this gamma function will give us one result, and then there will be a theta function and there will be a phi function. So it is, I think we have already done that one, right, just before some time, right? Cos square phi. So cos square phi d phi, it will give us as 1 by 2. Then 2 cos square phi was there, then 1 plus, then 2 pi. So it will come as pi. Simple. Similarly, from here it will come something, and from here it will come something. But as a whole, if you just calculate that one, I think I will not calculate right now this one. It may be a homework for you people also. There will be one answer. No, I will not tell the answer right now. But yeah, you can. Sorry? Like if you want to do that, that will be a very good one. So you can do that one. Okay, and you have to tell me which one will be the correct one. Okay, correct answer. So just take a screenshot of that so that you can do later also. And after that I will give you one more question, one or two more questions, but the time is not there, so I will not do that one. But you have to do that, but I think next class you can show me the answer. Okay. So just take a screenshot of that. I am going to the next class, next question. So see the next question. This is the next question. This one also you can do by yourself. See the question. Using the trial function, the function is there. Psi x equals to a x square minus x square in the range minus a, x, a and 0 otherwise. The ground state energy of a one-dimensional harmonic oscillator is how much? That is a little bit big question, but it's a very straightforward. We have to do the trial function calculation. Okay. So I think this is the last one. This is the last one. So just take a screenshot of this question also, and you can give the answer in the next class. Okay. So for the trial function, I think you know how to do that. Okay, I am just going to tell you a little bit review of trial function. So what you will do basically, at the very first, you will calculate the value of a. What is the value of a? You just calculate. How to do? You just do the psi star psi integration dx equals to 1 for the normalization case. Then it will come as a value equals to something. Then our psi will be fine. Then with the help of this psi, we can calculate h. We can calculate t, we can calculate v. So after getting the t and v value, we can have the value of e as t plus v. But you can see here in the t and v there will be a function of a, because you can see here it is a. But we have to calculate what will be the value of a. So for that case, what we will do, we will do as like dA equals to 0. From that condition we can get the value of A, and if I just put the value of A in that expression of E, then we can get one answer like that. So which one will be the correct answer, you have to tell me. Okay. So just take a screenshot of that. So we will come to the next class with these 2 questions as a homework, and after that we will do the next topic, like next week topic. I forget what is the next week topic, I have to check that. Okay, whatever. So from today onwards, like what we will do, we will talk about NET or some TIFR questions, as most of the GATE questions is already done. So, sorry? Solid state physics, right? Yeah. I have one like comment on that. See, basically the solid state physics I did not do that one because like 1 week I was skipped. So for that case I was a little bit lack of the week, because you can see that it is a week 12, but week 11 was not done because 1 week was skipped. So that's why what I did, I just skipped the 11.1 solid state physics right now, but we will do in the next, I think I will talk with the Nptel coordinator in some in between dates, like I am taking the classes each and every Wednesday, right? So maybe I can take a little bit extra class, so that in that extra class I will do the solid state physics, which one was skipped in week 11. Because I am going lack of that week, so that's why I just wanted to cover up that one. But I will definitely talk with the Nptel coordinator to have an extra class. In that extra class, I will do that solid state physics week 11 questions. Okay, but before that, I will not talk about solid state. Whatever the schedule is there, I will go with that one. But whenever the extra class will be there, in that extra class, I will do solid state physics. Okay. So that is the case. I skipped that one, so like not this one, I skipped a previous one, so that's why I am going to lack of that week. Okay, fine. So maybe there will be one extra class in between that next Wednesday and this Wednesday. Maybe in between that there will be one extra class where I will talk about solid state physics, or it may be more. I mean next week. I don't know when they will give the time. Okay, so for that today, and we will talk in the next class. Till now, bye bye, and just enjoy the semi-final. Bye bye. Stop sharing.